Well, everyone hopefully can hear us. We'll get started in a couple minutes. We'll let some more people join in. We're expecting about 250 people. We're halfway there, so we'll give them a few more minutes.
And for this recording, is an email going to go out from ESA for people to listen to the recording? Oh, you're muted. I can see you talking, but
I think everyone can hear us. Everyone can probably hear us. Yeah, there'll be an email that goes out with the recording link. It'll be on the page that says listen.
Perfect.
Yeah. Give everyone about a minute and we'll go. You ready, Sheila? Want to get started?
Sure.
Okay. Well, welcome everyone to ESA's first ever webinar. We've never done one of these before, so hopefully this all works out well. I'm Joe Chwanek, the Executive Director at the Environmental Services Association. Thank you for joining us today. If you can, save your questions till the end, and then we'll go through the chat box and we'll try to answer as many as we can. For now, I'm going to turn it over to Sheila, and Sheila will make her presentation for the next 40 minutes or so, and then we'll take questions. So just bear with us as we do a switch here.
Okay. Okay. So thank you everyone for calling in and having a listen to my webinar. Today I'm going to be presenting conceptual site models built for purpose. And again, I'm Sheila Dutchik, and I'm a geologist with SNC Lavalin. And this is our first webinar. So if there's feedback, that would be great to pass on to Joe. So, one thing there. Hopefully now you guys can see. I'm sorry, I had the webinar panel on. But anyway, so this is how I'm picturing you. This is a great photo that we had submitted for our SNC Lavalin best COVID meme of a conference call of what people are actually looking like working from home. And I'm pleased to say that I'm actually dressed and out of my pajamas today. So maybe you guys are too. So like I mentioned, my name is Sheila Dutchik. I am the service manager for hydrogeology and earth sciences at SNC Lavalin. And my focus is managing and providing technical support in hydrogeology for things like groundwater assessments, groundwater monitoring, operational compliance programs. So my main interest in my career has been site assessment work and specifically in characterization. And CSMs are logical tools that we use when you're doing site characterization work and doing those assessments. So I've been a fan of CSMs for quite a while. It's something close to my heart, and so providing a presentation on them is just a happy situation for me. So before a remediation technology or techniques or trials can be initiated, a conceptual site model, which we'll abbreviate and say CSM for today, they must be developed. So CSMs are a representation and a description of the site's physical, chemical, and biological understanding. And we have to develop and maintain these CSMs. It's a natural and logical approach to close data gaps, address uncertainties, and ensure that resources that we put into environmental programs are expended, that they're necessary, that they're focused, and that they provide high value. So today I'm going to talk about, what is a CSM, defining it. I'm going to give you some published examples that'll help, maybe in your mind kind of solidify what these things are. We'll talk about the evolution of a CSM. We'll discuss some of the key components of an effective CSM. And then I'll provide some examples from some actual project work so you can see how we've applied these successfully and maybe give you guys some ideas that might work for some of your sites. And I guess if there's one thought today or one theme, I want to relay to you that just because you might have a complex site doesn't mean that you have a complicated CSM. So we want to, the idea behind CSMs are we want to make things easy to understand. And so, taking that complexity out of it or the complications out of it is one of the goals. So understanding your data, understanding your site may be complex, but it doesn't have to be complicated. Oh, there we go. So when I looked through, okay, well, let's find some definitions of what a conceptual site model is. So, a good reference would be the Canadian Council Ministers of the Environment, or our friendly neighborhood CCME. And according to them, the definition is it's a visual representation and written description of the relationships between physical, chemical, and biological processes of the site and human and environmental receptors. So again, it's providing information on sources, types, and extent of communication or contamination, possibly releases and transport mechanisms, possible subsurface migration pathways, receptors, and routes of exposure. And we'd like to include land use and community concerns. And this is kind of mirrored when we look at the US EPA. So our brothers and sisters down in the States. A CSM definition for them is a summary of how the site became contaminated, how the contamination was and is transported, and where the contamination will ultimately end up and to whom it may affect. So some of the specific elements, like I mentioned, things like historical or planned future land uses, descriptions of the settings, the climate, the meteorological conditions, things like conduits or pathways, and information on your receptors. So the first example that's a published example, this was taken from the CCME Guidance Manual for Environmental Site Characterization. And of course, I picked a hydrogeology one because I'm a hydrogeologist. But you can see from this example that one of the key features that we're looking at is the geology and the geometry. So, we have things on the CSM that include water levels, hydrostatic pressures. Do we have contamination sources? And, are there surface water bodies or pumping wells or things like that? So it gives you a good snapshot of sort of what is the sandbox that your site is in and how are you going to play with this? Another example that the CCME has provided for a CSM is a risk focus. So you can see that, there's site characterization. It's to collect this data to understand the site and what are our site management plans. So the risk assessment, we're trying to understand 3 pillars, which are sources, pathways, and receptors. And I'm sure for those professionals that are working in this environment, we've seen the 3 pillars: the pathway, source, and receptor. And then another one that they have is, instead of having a picture of a CSM, the CCME also recognizes that there are things like webs. So they're tables that explain, okay, here's where we have some contaminants, here's some possible release mechanisms, some exposure routes and receptors. So you know, we might do risk management plans, and we can see here, okay, we have a good understanding of certain media, or we might understand some of the receptors, but it just shows where what we do know and what we don't know. So now I'm going to talk a little bit about the AP. So the AP has an environmental site assessment standard, and I've provided a link here. It's dated March of 2016, but there is a section in here that's quite detailed on CSMs, and it is the Alberta standard. So I thought it would be worthwhile to review a bit of that today. So like I said, this guidance comes directly from the standard, and the CSM tells the story of how the site became contaminated. And I thought that was really cute, how they have the story as if it's a fairy tale. How is the contamination transported, how it is being transported, where will that contamination end up, and whom or what it may affect. So a well-developed CSM provides decision makers with an effective tool that helps organize, communicate, and interpret existing data, but also identifies areas where additional data is required. So there is a risk with less detailed CSMs. You'll have to have conservative assumptions regarding the risks associated with the site, and therefore it can be difficult to rule out pathways and receptors. So for example, the more generic of a CSM, it assumes that you will have to have generic assumptions, and that's kind of the basis of how Alberta runs with the Tier 1 guidelines. So CSMs are iterative, and so it's important to start somewhere and keep building. And as you keep building, you'll be moving from generic to more site specific because you have more information to back up what your plans are. So, and again, the AP standard really supports that iterative nature of developing a CSM. So as site information becomes more detailed, your CSM is refined to provide information on sources, types, and the total extent of contamination, whether it's vertically and horizontally. And it helps you understand your releases, where they happen, and your transport mechanisms. What are your subsurface migration pathways and potential receptors and routes of exposure? So where do we go from here, right? So the specific elements, like I mentioned before, we want to know, you know, what was the land use, what is the current land use, and what are we doing in the future? So what types, what kinds of zones are we looking at? Our CSM is going to include detailed descriptions of the site and the physical settings. And as a geologist, I like to get kind of caught up in there. But it forms the hypothesis about the release and the ultimate fate of contamination. So these are just pictures of different land uses in cartoon format. We want to know specifically in our CSM, what are the sources of contamination at the site? What are our, you know, our contaminants of potential concern, and what media they might be in? So soil, groundwater, surface water, vapor, air. And I've included a few examples in cartoon format of salts, hydrocarbons, things like that, DNAPLs, PFOS. And then we also, not only do we need to know, you know, what contamination and what sources we might have or the affected media, but we also need to know what are the distributions of these chemicals within the media. So do we know concentrations? Do we know where? And this is just a picture of a geophysical survey, an EM survey. We also want to know, how are these contaminants migrating from sources, from the media and through these pathways? We want to know, what are these receptors? And information on soil properties, geology, hydrogeology. That's pretty important, because without knowing what the physical, you know, mechanisms are, we wouldn't be able to understand what contamination is, where it is and where it's going. Information on climate and meteorology is pretty important because this influences the contamination distribution and migration. Lastly, according to the AP standard, we're looking for things like what sort of vapor intrusion might need to be considered. So things like construction of the buildings, you know, things like foundations and ventilation, things like that, subsurface utilities. It's important because it helps us understand where pathways might be migrating or which contaminants might be migrating through. So at SNC Lavalin, we do have a preferred operating practice for our CSMs. So, you know, that's one of the things that I like to draw on is where we have defined tools and things. And so for us, in our preferred operating practice, we have the definition of a CSM as an analytical tool that defines the site, helps us understand site's physical properties and addressing site environmental issues. So this is really a framework for the site, and it's a description of the source, receptors, and pathways. We've mentioned in our operating practices that CSMs must be scalable. So they have to be able to scale up and scale down depending on what kinds of sites you're working on. And luckily, we've got quite a few CSMs that we can look at and compare from our site assessment and remediation team. There's quite a wide variety, and in some cases, they're very simple 2D sketches to complex multidisciplinary and integrated models. So, you know, we can run from anything as very simple to very complicated. And it depends on what are the objectives, what are the plans for the site? Do we have risk assessment? Do we have remediation? And what are we planning to do with this information? And one of the things that I thought I'd like to share with this group is that we express these CSMs as figures or as a series of presentation slides or tables. So the point of these CSMs is to facilitate communication, and it's understanding what information needs to be in the CSM depending on the audience that you have. So I'm going to ask all of our professionals out there, is this a CSM? And normally when you're not doing a webinar, you can actually look at people's faces and see what their response is. But in fact, it could be. If this is a site where, you know, you've just acquired this site, all you know is there's a water bearing zone sandwiched between two clays, that might be the CSM that you're working with. And so it's now up to you to figure out, okay, where do we go from here? So the benefits of using a CSM. So the earlier, the better. So the CSM will help provide definition and logic to your site evaluations. So using it early can identify data issues before you get too far along. So you know where your focus needs to be. It provides a format to focus these data requirements and lays out your problem. So what do we know? What do we need to know? And it'll help identify for you what are your sources, what are your pathways, what are your receptors. And I think to some degree, it'll clarify your project goals. So when you know what you have and what you're planning to do, you can have those discussions with your clients or regulators or even your field staff so that everybody's kind of working towards the same goal. Now, here's a warning for you. When I first started looking at some of the CSMs that are complicated or complex, don't get caught in the details of where to start. Just, you know, believe that the details will work themselves out as the work progresses. So start organizing your data, start getting your data into something that resembles a CSM so that you have this framework and that you're prepared. And then you'll start to see the site will start to become clearer as more pieces are added. So I have kids, and so I love having little cartoons in my presentation, which is why I've included the Cookie Monster. And so I just want you guys to remember, hopefully the image of the Cookie Monster, that data to a CSM is what cookies are to the Cookie Monster. So the cookie monster can never have enough cookies. CSMs can never have enough data. So when you're developing your CSM, it's a stepwise approach comprising desktop review of available data. So establishing that framework for your site geology, the geometry, your soils, your hydrogeology, really understanding, how groundwater flows within your CSM and what pathways exist. We want to, understand the extent of impact from the source and where are those risks to those important receptors that need to be protected. And finally, the assessing of those data gaps. So as your site is better understood, your CSM becomes further established. So what makes a good CSM, right? We've talked a bit about what goes into it, but what makes a good one? And again, I want to focus on that complex doesn't mean complicated. So the more effective CSMs, they're clear and they're focused on your message delivery. So you have all your data in, but then you need to make sure that you're able to tease out what's important and make sure that you have a method or a system of being organized, audience focused. So who are you talking to that day and what information do they need to know? And it provides those interpretations and a summary of your existing data and identifying where are you going. So what additional data do you need, right? So how complex do we need to be? And when is it too complex? It's too complex if you're losing your audience. So an effective CSM needs to be dynamic and scalable, which means that you need to update and adjust and then share new information as it becomes available. Which is kind of nice. I mean, that's why, we enjoy doing the work that we do, is that things change and that there's new information and you get to look at new data and make those decisions based on that. All right, so here you'll see, it's not a mistake. This slide is to feed our CSM. So right now, it's a blank slate. Can you see the message? Well, no, we don't see anything, right? So what if we added a little drilling rig and we go out and we collect some data? So we're going to go get some data. Okay, so we see, okay, at our site, there's obviously some letters and they're in a different pattern. So we need to decode this message. So how are we going to do that? Well, we're going to go do some more drilling work. So we know that there's a message here, it's hidden. We're going to keep looking, getting more information, and then you can see at the end that, okay, now we have all the pieces, we can fill in the pieces. So if we take that sort of process and we apply it to a site, we can look at this theory to show the evolution of our CSM. So for this one, we're looking at just two-dimensional for simplicity. So it's pretty simple in site. We have a former gas station at a corner of an intersection. And this is our cross-section view. So we don't know anything, we just got the site. So we decide, well, let's drill a borehole. Well, based on this, our CSM would probably be that we just have one borehole. We've compiled the information from this borehole. The framework, we can see there's one type of soil and there's impact in the red coloring. So we need to see what is that checkered red stuff on the screen. We don't know what our receptors are yet, so we're gonna have to do some more work. And we've identified we have some data gaps. We don't know how deep, we don't know to the east, to the west, but an appropriate CSM for this would be a borehole log. So we can, we see that we have information, we can see the geology that we've encountered, but that's pretty much where our CSM stops. So then let's drill a few more boreholes because we're hydrogeologists and site assessment specialists, so we want to do some more investigation work. So now we understand we have a source. We can start looking at who is this going to affect, how far are we going, and look at those data gaps. And we can plan for remedial option analysis, start looking at those feasibility options and looking at, okay, what do we know? And when we look at that, our CSM might be the form of a table. So we've got some boreholes, we've got some information, some data at different locations. So the fundamentals, if you guys remember from high school, there's 5 W's. So the who, what, when, where, and why. So when we're looking at this communication, you know, who are we preparing the CSM for? What are the site conditions? What are the contaminants of concern? When, how old is this problem? When did it become apparent? And what time frame do we have for the action that we need to be taking? And then where. So this is the most obvious place for practitioners, and we often get caught up in the where. But often it is important to go back and remember the other W's and the why. This is absolutely critical. It's the rationale for our selected approach. It's our roadmap of where we need to go. So it's pretty important to know the why. So this type of CSM, I thought I would include. So you can see that, you know, it looks like there's a lot going on here, but for the project team, they need to have one page where they can see a lot of different information. So they can see this data in a spatial format. So you can see there's utilities. If we're planning to do more site assessment work, they'll need to know that for logistics. We need to know the planning. We can see where we have impacts on different soil boreholes, where the contaminants are present, and it's drawn to scale so that we can see calculations and things like that. So there's a lot of information which might be overwhelming if you look at different audiences, but the project team, again, needs to see all this information. So what we do at S&C is we like to include Excel sheets where we have different tabs. And depending on the sites, they can be quite complicated with a lot of tabulated information. So we can see things like, okay, we have project information and land use and how do we get onto the site, things like that. We mentioned receptors and infrastructure. Are there any underground tanks and things like that? What are our areas of potential environmental concern, our contaminants of concern? We look to see, do we have things like aerial photographs? Do we know the geology? You know, is it Pascapoo that's underlying our site? There's a summary of well logs, so well completion information, and then a listing of reports and things like that. So not every site is going to be able to populate to this level of detail, but that's kind of what we tend to be working towards. So that, again, this is based on those people that are working on the project and the project team. They need to be able to know where to go to get different information. And because we organize all of our sites kind of in the same manner, anyone who starts working on something knows typically where to find information if we have it or not. Now, if you look at a different audience, like say the public, so maybe, and this is a fictitious area, this is fairy tale land, with a picture of an impacted area with some soil vapor extraction systems on the outside of our plume. But we have to go and get buy-in from the public. So for them, the CSM is going to include photos. They want to see, okay, my house might be located, you know, such X number of meters from this area. So I'm going to be interested in seeing the relationship and visualizing how this is going to impact me. They might also want to know, you know, how are the predicted results going to change? So in this case, we might have June of year one, and then show over time that this is what our expected results are showing diminished concentrations, right? We want to see where things are and why, right? A picture is worth 1,000 words. So this is why we would want to show relationships to different things, where things are and streets and things like that. So, and the reason that we would do it this way is we need buy-in from the public in the neighboring area. So it's better for communication purposes. If we were to show them this picture with all of the data and the lines, they would be overwhelmed and they wouldn't understand, or they may not get the information that we're trying to portray. Now, we might have a risk assessor. So if you remember at the beginning of my talk, the CCME has provided us with risk assessment type of CSMs. So a risk assessor, they are going to look at things like the geology and the geometry as well, but their focus is going to be on risk, right? So what happens if our SVE system leaves residual pockets of impact? So, what are the current and future land uses? And do we need to consider any engineering controls to mitigate these risks? So for this one, we might show things a little differently. So showing a person and when they're going to be, touching, so direct soil contact. Are we concerned about vapor inhalation? Are there any houses nearby that might be at risk? Do we have, are there any things like, what about surface water or groundwater? Is this going to be an issue? So you can see, okay, well, now we have something leaking into an aquifer. Is it a domestic use aquifer? Do we have a water well that's a water supply well for domestic purposes? Or is there something that might discharge and impact fish? So these are all things that, again, if you have a CSM, it's going to highlight where your site is and making sure that you understand those pathways. So like I mentioned before, I wanted to present some actual project examples because I think that will help some of the people in the audience to visualize, how you can apply this and how you can go forward with the application of your CSMs and when they've been used and where we have demonstrated success. So like I mentioned, we do use them for a variety of environmental assessment and even remediation work. We might use CSMs for estimating contaminant flux, predicting plumes, especially if we have areas where monitoring wells can't be installed because of the geology, or possibly because logistically it's just too difficult to get a well in. Sometimes we have to go back to the CSM. We might want to optimize our monitoring well location. So knowing where groundwater is flowing, where we have impacts, you want to poke in your groundwater monitoring well in a location that makes the most sense. We've used them for landfill, stormwater, runoff disposal options, developing remedial system designs, and to support risk assessments. So I'll just jump in here. So this one is our first CSM, and it's literally just a picture with a bunch of arrows. So, it seems pretty simple. What happened here was it was a historical derailment for train. So you can see kind of the train tracks on the bridge. And there was a release of contaminants near a major river. So part of the site characterization, we developed the CSM to explain the relationship between the sources and where they were going. And it was used to assist with remedial planning and was eventually integrated into a risk assessment and further developed to include biological and human receptors because of the river. But you can see how simple it is, and everything was summarized in this figure. And then it was prepared to show the provincial regulators, here are the complexities of the site, here where we have, physical constraints where it's difficult to get down to areas. You can see it'd be difficult to get a rig in. But basically it allowed the start of a discussion. So all the arrows and the information was somewhere that, we as environmental practitioners can speak to it, and just communicating between the client and understanding where the challenges are, using that photograph is really beneficial. And the budget for this CSM was about $5,000. And again, that's to put in information and attach it to a picture. The second example that I'm going to present is we had a historical fueling release that resulted in a contaminant plume for an aquifer with a very high hydraulic conductivity. So it was near a park, and it was up gradient of not just a river, but also a drinking water well. And the work was conducted during the initial assessment stage through to the construction of a large-scale remediation system. So because we had such a high conductivity in the aquifer, our Tier 2 guidelines were developed for the petroleum hydrocarbon parameters that we saw. So again, the spill was happening kind of up here on the top, and then made its way down through into this fine to medium grain sand. So it looks like this is a bit of a cross section, but this CSM was used. It was revised as we had more data being collected, and it was eventually incorporated into a numerical model of groundwater flow. So we were able to optimize well installation for other monitoring wells and develop a large-scale LNAPL remediation system. So we had to kind of model different ideas or test out through desktop study different ideas of how we were going to get this remedial equipment in place because of the steep topography. So the CSM was essential to developing our remediation strategy. And the simplified one that I'm presenting here was used for communication and included all the information that was needed for planning. And the budget for the CSM for this one was $35,000. So more information, but again, a lot more going on. Now this one, you can tell just by the picture, this is, a lot more resources went into building this CSM, and with good reason. So this CSM was completed at a petroleum storage and transfer facility. It was formerly a refinery. So there was a lot of site investigation and remediation work that was, done since the early 1990s. So there was a lot of data. A lot of contaminant sources, different hydrocarbon plumes, different pathways of migration, and different receptors. So in this particular CSM, there was software, and we used ArcGIS to assist in data interpretation and to provide illustrations for site conditions. So in this particular software, we're able to slice through the site and see things in different cross sections. And we had actually an environmental data management system, so almost like a database that to compile all the field data and analyze all the logs and the reporting and things like that. So we had to use statistical analysis between locations. We used our GIS mapping team and looked at things in 2 and 3D. So you can see that this picture here is an output for the CSM. Where we have the site-wide interpretation of the stratigraphy and interpolated soil descriptions. So we used the descriptions from each borehole log to, extrapolate and interpolate between. There were perched and regional groundwater regimes that we had identified, and so we looked at discharge areas and things like that. So when we characterized the 3 distinct contaminant plumes, we were able to look at the analysis of where things were moving, and all the soil and groundwater data was segregated into different depths based on our interpretation. And so the budget for this guy was $125,000. So a lot more information, but again, a lot more resources went into organizing and developing visual information. And we are finding that, particularly for our group, clients are looking at visualizing and really being able to see what's happening. And the software packages that we have available, we're revamping those all the time and getting better and better at being able to produce visual outputs. So the last project that I thought I would share with you guys is a pretty big mega project. So S&C, I'm lucky enough that we get to work on small projects to anywhere from large LRT designs, so light rail transit. So here's a groundwater model that was built, and you can see there's a mesh, and I'm just going to zoom in here. And on this one, you can see there's a track with a tunnel, and you can see those zigzag lines that move across. Those are actually bedrock fractures. So we had to map out fractures. We had to look, work with the rail engineers to develop CSMs and understand and make sure that where we were building the LRT track made sense. So we looked at hydraulic heads in the model domain, so we could run different scenarios to see, okay, well, do we need to de-water for making this tunnel? Are we going to have shifting of the track and things like that? And of course, the project budget's $100 million, but that's to build the track and everything like that. It's not just for the CSM, but going anywhere from $5,000 to $100 million for our CSMs. So lastly, I wanted to close with make sure to, always be feeding your CSM, get that cookie monster his cookies. And then finally, that, good CSMs are effective communication tools. So CSMs are analytical tools for defining sites, comprehending physical properties, and addressing site issues. They are as complex or as simple as needed. And so we do, as environmental practitioners, need to understand who are we preparing these for and what information is needed. So the effective CSMs are those that are clear and focused on message delivery. Effective communication can improve the quality and have more productivity of your environmental site assessments. Complex does not mean complicated. And that these CSMs should be dynamic and evolve as information is compiled, and it can be used to guide site assessment, remediation, and risk management. And with that, that takes me to the end of my show. So I'll just, I guess, take it back to Joe.
Yeah, thanks, Sheila. Okay, let's see. So if you raise your hands through your screen, I believe I can unmute your mic and people can ask questions. So let's give this a try. If anyone has any questions, or you can type them.
I'm just looking, hopefully you guys can see me on my webcam. There we go.
Does anybody have any questions for Sheila?
Oh, you guys are being easy on me.
Oh, wait, right, yeah. People are, just give me a second here to figure this out.
We have some chats.
Yeah.
Okay, great.
Is it possible for, oh yeah, will be copies of the presentation, the PowerPoint? I'm sure we can get copies posted. There's also going to be the recording of the webinar. Just give me a second here. Sheila, do you have any suggestions for free or simple software packages to produce CSMs?
Well, I mean, yeah, we do. Like I mentioned before, we use Excel. I mean, I know that's not free, but you would have that at your disposal. Things like even just drawing on a picture. We do use more complicated software, like Leapfrog is one that we're commonly using just to show the hydrogeology and all of the soil stratigraphy and stuff like that. But obviously that's not free, but it is a good software package. So hopefully that helps.
From Shirley, how important is superficial geology mapping at first CSM? Big words early in the morning.
Hugely important. I mean, superficial geology it's the framework. That's the component or the piece that generally that we work in as environmental practitioners. So, generally our field staff are working in those tills, the upper portion of things. So in Alberta, superficial geology, I think, is king, actually.
From Aylin, what do you find the most complicated aspect of assembling a CSM?
Honestly, some of the sites that we get or that we inherit, it's going through the information and trying to sort out what is relevant and what is information that is a red herring. And really just making sure that you have those different lines of evidence to make sure that you're proceeding forward with your site assessment in a way that will achieve the goals that you're looking for. You think having more data is always better, but sometimes you end up getting data that you might question. And so really understanding where that data has come from and how reliable it is, it's pretty key.
I have a couple of comments here that Health Canada has a free CSM model builder and PowerPoint package.
Perfect, thank you.
Yeah. What is the hardest soil type you've had to handle?
The hardest soil type? I don't. That's a question that I didn't think about. I don't necessarily know that it's one particular soil type. I'm lucky enough that I have access to a lot of people that are really, really strong in soil stratigraphy. And so we have experts that are PAGs that, all they do is work in soil. I think it's, finding those resources. You're not going to be the expert in every single thing, but I'm lucky enough to have access to those people and be able to talk to different soils people, I guess. And I'm also married to a soil scientist, which helps.
Can a CSM be transferred to a 3D math model?
They do, actually. Some of the sites that we are working on right now, just within my own group, we have Leapfrog, and then Leapfrog basically is just a platform. It's, I'm not endorsing necessarily Leapfrog. It's just the one model that we use at SNC-Lavalin. But Leapfrog allows you to put in different borehole logs and look at your site. You can even flip it upside down. You can do cross sections and things like that. And then we can take those Leapfrog models and then export those to things like FeeFlow. FeeFlow would be a groundwater model where you have to build the geology first, and then you can analyze where things are going based on the hydrogeology model. So being able to have those pieces talking to each other is pretty important. And unfortunately, that's not my specialty. I am a hydrogeologist, but I don't do the computer-based modeling. Luckily, I have people that help me with that part.
A few more. What's the most common feedback from regulators regarding CSMs?
They want to make sure that we have clear understanding of being able to transfer that information. So, our regulators have to look at a lot of sites. They have huge stacks of things on their desk, and they're trying to get through these. And so it's important that these snapshots that they get is as clear and as simple as it can be, so that they don't have to spend time looking for where did you find this, or where did this piece come from. So double check your work, make sure that you don't have typos, because that allows them to really focus their efforts on what they need to do.
What else? Question again about the Health Canada experience using it, or with the AER's contamination management tool and resources. Any experience with either of those?
No, I haven't used the Health Canada one or the AER one, no.
Okay. Despite the variability of soils geology within Alberta, can you advise on a routine or common number of ground wells installed at sites to assess lithology, groundwater flow characteristic? This is asked in consideration of the Alberta Groundwater and Monitoring Directive.
Right. Well, so I love to put in groundwater wells, and obviously I feel like if you're drilling a borehole, why wouldn't you complete a groundwater well? But of course, we have limitations with budget and logistics and things like that. So we have to be realistic. I think, you know, you try and as you're doing these programs, these site assessment programs, you need the number of wells that you need to make sure that you understand the site. So I know that's a wishy-washy answer, but it really depends on the geology. Like we have sites where you might have one unit from surface all the way down to 30 meters. And so that doesn't seem like, you know, if you may have different layering in there. You might have sites where you have bedrock, so you might need to have, you know, different layers. We have sites that have up to 5 aquifer units, and those might not necessarily be different geologic units, but certainly we have A, B, C, D, E wells. And it just depends on the characterization. It also depends on how far do you need to assess. So what are the contaminants that you've run into? Where are your receptors? Are you worried about things that are going down gradient or possibly moving down vertically? And so, you know, like I said, I'm sorry I can't say, well, you need a minimum. You know, we obviously need a minimum of 3 wells in order to tell groundwater flow direction. But there's lots of different reasons why you would do a site assessment. And so why you would put in groundwater monitoring wells would be really site specific. So it's tough to answer that question.
And I'll say I have 2 more. What's the most neglected part of a CSM, and how can we gather the data to find that information?
Easily the most person that is overlooked is the audience. So when you're putting things together, you know, you might have a CSM that, like, just like I explained, that our project team has a ton of information. It's overwhelming how much information there is, but it's organized. So we can find it because we're used to working in those with those platforms and with the different versions, whether it's Excel or Leapfrog. But it's knowing that, okay, I need to explain to this landowner, or I need to, you know, I have to talk to a regulator who's super busy, and, you know, I need to make sure that they understand, you know, very quickly what's going on and clearly what's going on. So, you know, those 2 audiences might be different. They certainly are different, and they certainly have different data needs. So always consider who are you doing this for and why? Why are we doing this assessment? Are we looking for risk assessment? Are we looking for closure? Are we, you know, these are the things that have to be the very first thought. And sometimes I think we as practitioners can't see the forest for the trees. We like the data. We got into this business because we like looking at data, and the need to get more data is almost like an addiction.
Last one. You mentioned at the start to use CSMs early. At what phase of environmental site assessment do you recommend?
Right from the beginning. Like I right from the very beginning. So, okay, I don't know anything about this site. What do I know? So are there any reports I can find? There's no reports. Is there any published information? Do I know, am I going to be, where am I going to hit bedrock? So, you know, there might be publicly available maps. Do we know, like, why are we going out here? What was spilled? Or is there an issue, or weird grass that's depressed, or things like that? So you can start with that and then start building from that, because again, you might only know that you have to go to location X, but you need to start somewhere. So that's where you start.
Okay, that wraps up our first webinar. Thank you very much, Sheila. I really appreciate it. It was a great way to start, and remind everyone to check our website. We have lots of webinars and adding more every day, so please check them out. Everyone stay safe and healthy. Thank you.
Thanks. Bye, guys.